Your next challenge is called Find All Pairs, 7 Caillou series. Let's read what we have to do. You are given an array of integers. Your task will be to count all pairs in that array and return their count. Note, array can be empty or contain only one value. In this case, return 0. If there are more pairs of a certain number, count each pair only once. For example, consider an array loaded with 4 zeros. The return value is 2 because there are 2 pairs of zeros. Random tests, maximum array length is 1000. Range of values in array is between 0 and 1000. Okay, that's fine. And then we have some examples. 125652 returns 2 because you see this 2 is matched with a 2. And you have a 5 match with a 5. The 1 and the 6 don't match, and so we just had 2 pairs. And then go ahead and look at this example as well and convince yourself that it has 4 pairs. Should be pretty easy to see. So I think that's clear. Let's go ahead and get into the challenge. Make your attempt and come on back when you're ready. I'll start with some magic. So think about how you want to approach this problem. I thought this would be a good opportunity to show a new data type collection that hopefully you find useful for your work. It's called a hash set, and I'm basically going to use it to sort of, well, here's the idea. I'm going to scan over all of the elements in the array, right? So I'm going to start at the beginning, and I'm going to, as I encounter numbers, I'm going to check against my storage collection to see if I already have that number in it. And if I do, then I will say, okay, I have a pair. I will remove the value that was just paired from my storage collection and then continue. So you can imagine this running like encounter the value 1. My storage collection is empty, put 1 in it. It can't, you know what I mean? It doesn't have a pair because it's empty right now. Good. I go to the second element, find 2. I check my collection. Is 2 in my collection? No, my collection only has 1 at this point. So I add 2 to the storage collection as well. Go to the next one. Hit 5, same thing, right? I check my storage collection. It has a 1 and a 2 in it. That doesn't match with 5. So I'll put the 5 in there as well and continue. Encounter a 6, same thing. I only have 1, 2, and 5 in my collection. 6 doesn't pair with anything. Add 6 to my storage. So now I have 1, 2, 5, 6 in my collection. And then finally we get to a pair, right? We'll come to the number 5. We'll check our collection. It'll say, yes, I do have the value 5. And so I'll have a separate integer variable that's counting pairs. It'll be 0 to start. And I'll say, go ahead and increment that to 1 now. And then it's very important that I remove the 5 from my storage collection. So I'll have that part as well, remove the 5. That way, if another 5 comes up, it has to start all over again to make a new pair. And then we'll get to the value 2. We'll ask the collection. At this point, the collection would have 1, 2, and 6 in it. It will match. It'll say, yep, I have 2. So I'll increment my pair count, and I'll remove 2. And then I'll be through the whole collection, and I will return my pair count, which would be 2, right? That's what the contract says. We have to return an integer marking the number of pairs. So why don't you check out the hash set class? It's a good container to use here. And if you were struggling and my strategy makes sense to you and you want to try that, you can go ahead and pause at any point in the video if you just get an idea and want to see if you can work it through on your own. Even if you get part of the answer and think you can do it from there, that's really good for you. So the thing to know with a hash set, it represents a set of values. Okay, that's kind of general, right? There's a better description down here. We don't need to know about merging it. Here, this is the good part. The hash set generic type class provides high performance set operations. A set is a collection that contains no duplicate elements. That's good. I didn't want duplicates. And whose elements are in no particular order. And we don't really care, remember, in that storage collection, if they want to put the 6125, it doesn't matter. We just need to be able to access the values in there quickly, which is why I opted for this hash set instead of, say, a list, or I wouldn't use an array, but a list. And then go ahead if you'd like to read more about it. This is kind of the bit. It's a high performance. You get high performance set operations similar to accessing the keys of a dictionary or hash table collections. And so if you are already familiar with a dictionary, you can just think of a hash set as not having values, meaning the key itself is the value. So if you're familiar with dictionary, that's good. And this idea of hashing is important because it allows you to access elements quickly. And that's why I don't care what order the elements are in, but I do want it to be able to look up to see if a value's in the collection quickly, right? So if I just had a general list, right, and imagine we're kind of stepping through and we want to know, hey, do you have the value 5 in you? Well, I know this isn't really specified to you at this point, but it matters how these data types, these collections are implemented in performance of how fast they can do certain things. Now remember, there's no perfect collection, right? Some collections like hash set are good at some things and not good at others. Same thing with a list. It has its benefits and it has its drawbacks. The thing that scared me about the list was, let's say I want to see if a list has the value 5 in it. You know, it's going to have to go at the beginning of its collection, right, and sort of step through, if it's implemented like I'm thinking in my head, a list where each element is sort of pointing to the next element, and it's got to possibly go through scan the whole collection to find a value, or say definitively that it doesn't have a value in it. And so you can imagine that doesn't matter when we had 4 values in our collection, but what if you had millions of values? That's a huge performance hit. So these hash sets do some things under the hood where their power is that they can access elements quickly by assigning. They have a hashing algorithm that can help you get to the keys very quickly. It'll map the key to an index position, and so you can do that really fast and constant time. So, and you can imagine there's some you can have some conflicts, right, with when your hashing algorithm isn't perfect, where you get 2 different keys that map to the same index. And we won't go into the full details of hashing and hash sets here. There's lots of good resources about that, and we can certainly go deeper if there are any questions. But yeah, the hash set has to deal with those kind of problems. But I think it's a good choice here, and it's a chance to learn a new collection. So let's try that for our little storage container. So I'll go, and one thing, right? We know what we have to do. Usually at the top, they tell you where this comes from. And like lists, system collections, generic. So we know that. We've used that library before. Let's bring it in. System collections, generic, because we are going to get yelled at if we call for a hash set and they don't know what we're talking about. Hash set, and our type's going to be integer, right? We're dealing with ints. And I'll call mine unmatched, something like that. And then we've got to initialize it, right? New hash set of int, then we can use it. And then I also mentioned that we're going to have this, you can think of it like a counter. I'll call it pair count. And we'll initialize that to 0, and when we encounter pairs, we'll simply bump the value. Now what, right? We've got to start going through all the values in our array. So how do you do that, right? You can use a for loop for that. Let's try for each integer n in a. And if this a is not named well, you can call it something else. You can call it input array or whatever's meaningful for you. Clear. Okay, so do you remember how I described the strategy? We're going to start, it's going to grab numbers from left to right there, and we're going to examine them. We need to check if it's in our set, right? And so let's go back to hash set and see what kind of methods we have at our disposal. Should be something, hey, this looks promising, right? Contains, that's probably exactly what we need. Should return some kind of Boolean, I would expect, right? Yeah, Boolean, true if it contains the object. If it doesn't, it tells you false. That's nice, right? So let's leverage that. If unmatched contains the value, n, right? That's it. So that's what it boils down to. Our unmatched set is either going to contain the value or it's not. And we got to handle each case. So if unmatched contains n, think about what that means. That means we've encountered a pair, right? It means it does have the value. We're looking at a current value, and it is already contained in the unmatched array. So there's a couple things we need to do, right? We need to increment the pair count. Say we need to record that pair. And then finally, we need to remove the matched value from the list, right? Because it's got to be, you can't keep using it. You saw in the example with all the zeros, right? They counted that as 2 pairs. So you got to clear it out and let it build a new pair again for that value if necessary. So we can say, you'd have to hope now that hash set would offer a way to remove elements. Let's make sure it does. Remove probably, right? You kind of scan those names. So you don't have to remember all this stuff. You go to your list here of methods and you can usually find what you're looking for. And yeah, you give it the item that you wanted to remove. Remember, t for us is integer. So we'll pass the integer value that we want removed. And additionally, you don't have to use this return value, but it will tell you if it was removed or not, in case that's helpful for you. So, and then the examples are always nice, right? Numbers contain 0, remove, and then just put the value in that you want. So I think that's easy enough, right? Let's go unmatched, remove, n, right? We made our pair, we cleared it out of our little unmatched list so it can possibly build up another pair for that same value. Cool. And so what's the other scenario, right? This is the case that we're going to hit when we first start running and we're at this 1, and unmatched is empty, right? It doesn't contain anything, so there's no way it contains the 1 at this point. So what do you think you should do in that case? Well, there's no pair made, so we don't have to increment the pair count, but we should add that value to our unmatched list so it can potentially be matched with subsequent elements in the array, right? So let's do that. And what do you think? Hash set, how do we add an element? Let's scan our methods list here, right? We were in hash set methods. Would you look at that? Would you just look at it? Add. Perfect. Adds the specified element to a set. T is integer for us, so we'll just call add like they do here. Pass the integer value you want. So we'll go unmatched, add, n, right? N's the current value we're dealing with. And so we covered the 2 cases, whether it's in the set or not, or incrementing our pair count as necessary. And you can imagine when you get past this for loop, right, you've processed all of the values in the array. So let's fulfill the contract of the method and return our pair count. That's what they wanted, right? So I'm going to test mine. I think I did everything we have to do. I brought the library in. Let's make sure. Let's go for that green. Go for the green. Nice. Okay. Don't get cocky yet though, right? We got to run the attempt to make sure it passes there too. Nice. We're cleared to submit. So if you had any comments or print statements to help you out, now could be a good time to clean that up. get rid of these. It's just a single line. And yeah, they'll make me run it again so I could submit. I'll submit it like that, and then you know what to do. Go through the other solutions, see if there's anything that you can learn. And yeah, you knew the link stuff was coming, right? That's cool. That's a nice short way of doing it. May not have seen group by before, so you know what to do. You go look all these methods up that are new. Try to understand how they work. Yeah, I seem to have some pretty good variation here in answers. So yeah, hopefully that's clear. Hopefully you learned a new collection there, hash set. You can start using that when it helps you. Otherwise, hit me up with questions, and I will see you in another challenge.